Okay, all right. So basically finishing off the lecture, which was far too long last week. So data and data infrastructure, second part. So last week I managed to get through one of the 4 sections, volunteer geographic information. Today we'll whip through the others which are shorter. First of all, I'll sort of introduce my idea of a data ecosystem. Then we'll go talk briefly about spatial data infrastructures and then the digital earth. And I'll go through it quite quickly because I think to a certain extent the most informative bit we can have is actually a discussion about the digital earth, whether it's a good idea and whether it's practical. So we'll press on with that. Okay, so first of all, the data ecosystem. So what do I mean by the data ecosystem? And I'll emphasize that I call it the data ecosystem. Nobody else really calls that, although there is a big book called The Data Ecosystem that is about 10 years old, and is not exactly about the same thing, but it's sort of similar. So basically this is the idea that data doesn't just exist in files as data sets. You've got this clean version of the world, let us say, where you've got organizations collecting data, putting them into data sets, and then disseminating them and people using them. Or it may be individuals collecting data and then making it available for other people. But the world is far more messy than that very simple linear view. Data collected, made available, used. And this sort of diagram is one of my attempts to sort of show how sort of more complex the world is becoming, and increasingly more complex. So I've got 3 different types of agents in the system, so to speak. We've got the parties who collect and disseminate data. Individuals, organizations, okay? They collect the raw data, they're the primary data collectors. They may be national mapping agencies, they may be you. Often, and this is indeed before we had a sort of GeoWeb, what would happen is somebody would ask for a copy of a data set to be copied over to them, usually on a CD-ROM or something like that in the days before transfer by network was available. It might get passed on a USB port. But the basic point is that individual parties are exchanging copies of data among themselves. So the water department needs a copy of the Ordnance Survey base map, so they exchange it with those. Okay, so it's a one-to-one sort of peer-to-peer exchange of data, one could say. So copies of data were generally, were held and created by a certain group of people or organization, a certain person, and it was sort of the whole lot, or a subset of it, was exchanged with other individuals. Increasingly, there is a need. There are other ways in which data is disseminated. And this slide was originally drawn up from the perspective of scientific data. So, for example, there's a data repository called Dryad, D-R-Y-A-D, which is originally was set up by one of the places where I did a postdoc, the National Evolutionary Synthesis Center in North Carolina. And its purpose was to store data. So when scientific data, so when somebody submits a paper to a journal and it's accepted, there's the data that goes behind that paper, and as part of the journal submission process and the acceptance of papers, one of the conditions is that the data gets deposited in the Dryad repository. It started off with evolutionary data. It's now being used by many different groups of scientists, and it's increasingly, I think they've got sort of several hundred journals now where there's a requirement to deposit the data into a database repository. And this repository is what you would call, it's kind of like I think it's built on what's called a DSpace database. Basically, you've got these blobs binary large objects, which could be an Excel spreadsheet, could be an Access database, could be one of lots of different file formats. And then you have some metadata associated with it, which links it to the paper. So you have the paper points to the repository record, which has a metadata record for what that data is, and then you attach the data file to that record. But the data itself is not immediately accessible, perhaps through that repository. Other things, places, the repositories actually are maybe are a bit more sophisticated, and they're repositories for a particular type of data. So you may submit, so last week I talked about the hashtag system, where individuals, parties would potentially collect data, and then they would post it to the hashtag repository. A very basic system in that case, but it still acted as a repository. And these effectively make copies of data produced by individual parties. So we now have the copy held by the individual, and then we have the copy that's been uploaded to the repository. Increasingly, so that's a sort of copies, a repository. You could make a copy of the data there and make it accessible. But there are also organizations that run things which are called aggregators. And the one that I'm familiar with is, and I've mentioned before, is GBIF, the Global Biodiversity Information Facility. That is not a creator or particularly a storer of data. What it is a whole load, is a standard view onto a whole set of organizations that agree to supply their data in a particular fashion. In the case of GBIF, it's onto museums and museum record systems. So the museums keep the data, and all GBIF does is basically provide a portal that allows you to access all the data in all the museums that sign up to the GBIF system and are part of the GBIF system. So those are not necessarily copies. They don't really maintain copies, unlike a repository. It's more like they're sort of passing on the links. But because of the speed and the data, the volumes that are required, often I think what they do is they kind of create a local cache of the data, a temporary store, so that when you're inquiring of GBIF, they look at the local cache rather than going all the way back to the museums themselves. So it is kind of acting as a repository, but they're not the primary custodians of the data, unlike the repository, which has become the custodian of the scientific data, okay? So this is providing a window onto to lots of different data sources that are very similar or the same, but they may have a local cache. So every 24 hours, they may get an upload of new data from the local museums, but it's ultimately the museums that are maintaining the data sets as they go along. And of course, individuals want to use the data both from repositories and from aggregates. So they download the data from the repositories, they download the data from the aggregates to create their own new data sets, which they use in science potentially. They publish publications. That data gets posted to a repository. You're getting the picture. It's not just that there's one item of data, suddenly you've got data moving all over the place. It's starting to get fed back into the system. Things are potentially getting a bit more complicated, a bit out of control than simply, can I have a copy of your data set? And away you go. So what happens in the data ecosystem? Well, one of the major issues is data gets duplicated constantly. It gets duplicated, and of course some data is erroneous. It's got errors in it. Some data, as it gets updated, data gets updated, so if you go to the original supplier, you would get an updated version of the data, but because you're getting something that's in a repository that was stored maybe 10 years ago, maybe you're getting the version from 10 years ago. Okay? Increasingly, as this data gets churned about, it's difficult to understand where that data originates. So one of the things, I'll step backwards a moment from that and say, okay, one of the things when you're using data, from other sources, you have to understand what it is, where it's come from, how it was created, what are the issues with the data, is it fit for purpose? So you need to know, to be able to trace the lineage of the data. And with something like Ordnance Survey data, it's very clear what that lineage is. There's a standard data collection protocol that they go through, which results in a standard database product. But when you're using data that somebody has collated from a whole variety of sources, some of which may be out of date, some of which may have been changed by other users, it becomes very difficult to track the lineage of individual items of data. Some other little points on the data ecosystem, that data providers often have different perspectives on the world regarding the same kinds of data. And one of the classic examples is astronomers and astrologers. They both have information about planets, but they have different perspectives on what that information means. So if you're looking for information on planets, then you've got to be careful that you're in the right world. You're either dealing with astronomers or astrologers, depending on what your particular interest is. And another thing to bear in mind is that some data providers lie, either meaningfully or not. Some data providers, especially sort of on the commercial level, and indeed individuals are all prone to lying, you know. For example, you want to have a better web profile. You want to be seen to have got more data, so you invent a few data points. It's not unusual. A number of scientists have been caught out through corruption, falsifying data. It is not that unusual. It's not that common, but one should always be wary of it. There are lots of other reasons why data providers may lie. They might be trying to, I'm going to watch out for my language here, but they may be trying to upset or undermine, say, a competitor. So they're providing incorrect information because they're trying about the competitor. So bear in mind that the information especially regarding lineage, you may be getting wrong information. It may be incorrect. So it's a mucky world. So the classic way, of course, of understanding a data set's lineage is the metadata, which I hope you're all familiar with, which means the data about the data. So things like who, what data, who collected the data, what the data is, where it was collected, what's the coverage, the geographical coverage, when it was collected, how it was collected, and to a certain extent, why. Why is not often a most important thing, but it can give sometimes a clue as to sort of what the motivations for the data collection was. And when you've got ultimately the answer, what you want to get from your metadata is the data fit for purpose for what I want to use it for? But clearly, as we've seen in the data ecosystem scenario, it's a lot more difficult to understand whether your data is fit for purpose compared with whether you're getting data from the Ordnance Survey or your local water company or something like that from a sort of, you know, a professional supplier. And indeed, from the VGA perspective, which we saw last week, there are all sorts of questions over, is the data fit for purpose? I don't want to go into great details on this. How do we maintain this? How do we encode the metadata? Well, we use metadata standards. We all know that standards help interoperability. They standardize how data is presented, and it's exactly the same for metadata as from normal data. So a metadata standard will define a set of fields and agreed rules for filling the entries in those fields. So you may have mandatory or optional fields. You may have domains. You should be all familiar with domains, sets of acceptable values to go into a field. You may have things like controlled vocabularies, so a list of acceptable land use classes, for example. And because data comes from many different places, so you'll be, as GIS people, you should be very familiar with this. So you may be dealing with data that are collated by national mapping agencies and are clearly sort of geospatial data. But you also may be dealing with data that's come from, say, the census, which is maybe primarily related, interested in sort of human data. You may I integrate data from the biodiversity informatics field, which is primarily collated by biologists rather than geographers. So we're bringing together data from different types from different places, all in a GIS context, having common spatial georeferencing. So just as you want your actual data sets to be in the same coordinate system, to be able to integrate them together, you also need to, if you're integrating data, the metadata from different sources, you need a standard metadata structure to be able to integrate those metadata information. So disciplines each have their own needs for metadata. So a biological system, a biodiversity system will have different needs from a national mapping agency, which will have different needs from a social science perspective. So there's lots and lots of different data standards. But if we share fields and share definitions between data standards, then that makes integrating our metadata together much easier. So a lot of data standards, in fact the vast majority of them, wherever possible, they share common fields. And the mother, or I call the mother of all metadata standards, is called, on the internet, is called Dublin Core. How many of you heard of Dublin Core? Yeah, 1, 2, yeah. Dublin Core. And Dublin Core is the sort of WC3, I don't know whether it's a WC3 standard, almost certainly is, for all digital resources on the internet. And this is basically the main heading field. So you've got things like, well, you can see the main titles here. Software, is it a sound, is it text, is it a moving image? So all these types of data sets, including geographical data, potentially can be encoded with a Dublin Core metadata. And it includes things like what's the title of the data set, or the thing, the digital object. When I say data set, that could be a picture, it could be a video, it could be an ebook, it could be anything like that. Subject, who created it, does have a little section on geographical coverage, but it's basically bounding boxes or a word describing the geographical location. And the type, and this is the type list here, so it can be a collection, a data set, an event, an image, interactive resource, etc., etc. Other data standards, such as the Federal Geographic Data Committee Standard, the FGDC, which is the Federal Geographic Data Standard in the US, takes, wherever possible, takes the Dublin Core fields and uses those as the definitions, and then it adds on the other additional metadata fields that's required for the geographic data onto that on the bottom. So it expands it out. So if you remember your object modeling, you could say that the Dublin Core is the superclass and the FGDC is a subclass of it, yes? So it shares all the fields of the higher Dublin Core standard, but it has a whole load of specific fields relating to geographic data. And it's used, FGDC is just one example of a spatial metadata standard, and you can see in the US it's used by a lot of different organizations, and therefore they can share their metadata as well as their data relatively straightforward. But, okay, metadata is great, it goes with a data set, but users increasingly remix and alter data, as we saw in that diagram of the ecosystem, the data ecosystem. So not only is data being exchanged and duplicated, it's being remixed with other data sets, and really importantly, it's that those users are altering data as well. So you've got a set of data, and then you've got a slightly more updated data set for, say, half that data. So they take the good half, they take the good bit, and throw away the old bit, which is a bit out of date. So now you've got a remixed data set that's not, isn't the same as the the two original data sets is a mixture of the two. And it's a real problem as to how we track the data lineage of individual data items rather than data sets. Okay, it's the same principle, but you want metadata associated with each individual item of data, and that becomes a whole order of magnitude more complex. And indeed, next week's lecture, I'm going to introduce the semantic web, which is a kind of an attempt to deal with these issues. Okay, so that's sort of what I'm going to talk about, the data ecosystem, and this, to a certain extent, that was, I almost was going to move that to the beginning of next week's lecture, but I decided we'd just keep it in there. To a certain extent, because it shows spatial data infrastructures are one way of sort of coping with this, this proliferation of data to a certain degree. It's not a great one. It's not really to do with this. It's more to do with providing standardized data sets, but they're kind of related. And you'll see in a minute, they're aggregators, basically. Or they have a role as both aggregator and of a sort of repository. So what's a spatial data infrastructure? Sorry, I keep looking up there. I've got no screen here to see the things. So basically, they're a geospatial one-stop shop web portal by theme or geography that facilitates the discovery, evaluation, and reuse of data. That's their sort of purpose. And they provide often different views onto resources. As I say, it's kind of repeating. No, it's not quite repeating. So you may be interested in data, lots of data to do with a region, say the southeast of England or London. But you're not interested in the rest of the UK, you just want London data. So you've got you want a regional portal onto the data. But you also may be interested more in thematic data. So you're interested in land use, land cover, things that affect land use, rather than a particular geographical extent. And often these data infrastructures provide both kinds of approaches to the data sets, these data sets. A spatial data infrastructure is not another database, but its components, technologies, policies, and institutional arrangements that provide access to data without actually managing and looking after the data and necessarily holding a copy. They may hold a copy, but chances are they provide links through to the other people who look after and manage and provide the data, create the data. And it's as much about collaborative communities often as it is about the actual data itself, and we'll talk about those in a minute. And it provides a consistent view onto the data and consistent means of accessing data. So for example, when you search on your spatial database infrastructure, you should only ever get one copy of the data, hopefully the most up to date. So it's consistent. You're not ending up with 5 different versions and you're having to decide which one is the most appropriate. They've kind of QA'd it and said, look, this is what we recommend as the best data set. This is the current data set in this that's available. And of course, that requires metadata standards, because you may be presenting information that's been collated using different metadata standards or different formats. They need to be brought together so that you're providing a consistent metadata interface, and also that the data is provided in consistent formats. So you can always download shape files. One of them's not in a map.info format and another one in a DXF format and another one in a shape file. Wherever possible, they're provided in one single format, or indeed many formats. But you can always say, I want them in DXF, or I want them in shapefile, or I want them in map.info format. And it says there, including projections. So it's taking away a lot of the effort required, the GIS expertise in locating data, bringing it, retransforming it, subsetting it, etc., etc. So this is an old example, 2003, and this has been withdrawn. This doesn't run anymore, but it's still quite a useful image. And you can see how it fits onto the ecosystem kind of diagram here. So here's your web user. Here's your varieties of organizations. And this was the original National Spatial Data Clearinghouse in the US, federal system for accessing spatial data. And you can see we've got federal agencies, state agencies, universities and industries providing the information. These are the data holders. The FGDC gateway provided a single interface onto these all these various data sets. So rather than the user having to go to the industries, the universities, the state agents individually, they go through the FGDC gateway, which provides a window onto these other data sources. And here's a few you might want to look at: the Canadian Geo Connections, Geodatabase, FGDC, Inspire, etc., etc. So I'm not going to go into any of those. So, well, we'll just see a little bit of the geoconnections, the Canadian one. So in this case, I'm interested in topographic data, so I'm going in from a thematic perspective. I just search, just have a search box like Google, stick it in, I want topography. I get a return of a whole load of information on the various data sets that it references, scales, etc., standard return for all these different data sets. And then when I want to actually get the data and download it, I click on them, and what it actually does is it takes me to the geodatabase website, which is the interface provided by the Canadian topographic surveying. No, I can't say I'm an expert or I don't know anything particularly about Canadian how they organise their sort of geospatial database collection, but it comes through to here, which allows me to actually download the digital elevation model. So in this case, it's not actually providing me a link that directly allows me to download the data, but it allows me at least to get through to the web page that should provide me that data. Okay. And we can also go, and then it allows us, as we can see, we can do various other searches. I'm not going to go into any great detail, and I was going to have a read, didn't have time to read it. Okay, so that's a kind of federal example of providing access to sort of QA data sets collected by governments and other organizations. But not everything, all organizations are quite as large, sophisticated and developed as sort of the Canadian federal government and the American federal government. So, but these same ideas can exist at lower levels, and I'm just sort of mentioning this one as an example of a community spatial database infrastructure initiative, Nature SD+. And basically this is not providing, this doesn't provide a large portal that allows people to access the data, but large amounts of data, but it's a community online whose aim is to promote best practice in data collation and data organisation and provision. So it's a community, it doesn't have many resources compared with the federal government of the US, but it promotes best standards, the harmonisation of the data sets and devising a metadata standard for conservation data. So they're trying to create the community and to get people to organise their data in a standardised way, and then that makes it easier to plug it into some kind of infrastructure providing access to that in due course. They're not actually providing the infrastructure, but they're trying to get the community in the position that when an infrastructure comes in, it's relatively easy to implement. It's about implementing technology rather than cultural change. As we all hopefully know, cultural change can be as big a problem as the actual technological implementation of equipment, and that's what it looks like. So here's an example. Well, or not, as the case may be. We've had an example. I'm afraid this is and this was chosen without, this was a previous year before I knew any Botswanans would be here, I hasten to add. So this is an example of an attempt to implement a national data infrastructure in Botswana, and this is a kind of post-mortem of what happened. And this is what, if you go to the website, this is what you get. It didn't happen, basically. But the important things is, why didn't it happen? And then it's quite a good paper because it provides this whole list of things that you need to consider to make an SDI work. And it's a reasonably standard list, but you've got to have a specific purpose for the SDI. You've got to demonstrate the direct need for share the data and resources to the organisations who are participating. You've got to have good communication between the stakeholders. This is as important as actually linking the data itself. As I say, the culture is as important as the technology. Leadership. So you've got to have people who know what they are doing to lead the project and to have the consistency and are kept in place long enough to help implement it. You've got to provide a skilled workforce, you've got to have funding, you've got to have trust and authority so that the people who you're providing, saying, okay, we want to provide a window onto your data, so that they trust that you're going to do it in a sensible way and you're not going to start giving away data, that you're going to cover license agreements, all these kinds of legal things, data security. You've got to have an interface, a usable interface with a minimum of domain-specific technology, so it's got to be usable by usability. Again, going back to the beginning of our previous lectures, you've got to have a usable system, you've got to minimize local setup costs. It's best to build on existing systems and services rather than trying to top-down imposition of whole new systems of working. Positive feedback, something we heard from VGI last week. You've got to get, you've got to have your well, I think that in this case, no, positive feedback is in the effect that once you get systems up and running, the more you get in them, the more usable they become. So this is a sort of social network feedback effect, okay? So if you've got a system that only provides access to data from 3 organisations, that's going to get a lot less than if you've got 20 organisations participating. And you need robust partner organisations with adequate resources. So not only has the SDI system got to have adequate resources, but the people whose data you're trying to use and make accessible also have to have the resources. And that has been a real problem with GBIF, and particularly a lot of the smaller museums in the world and the museums in less developed countries, where they don't have the resources. They'd like to make their data available, but they don't have the resources to invest in that, to get the system up and running and make it available. All right, that's SDIs. So, Digital Earth. So this is the greatest sort of SDI sort of project or idea that's ever come up. So, 1988, Vice President Al Gore then made a speech at the California Center in Los Angeles. And it was a vision of a digital Earth, a multifaceted computer system for education and research. Access to all that is known about the planet and its inhabitants' activities, and to provide modelling facilities to predict future conditions. And in 2008, Grossner et al. In Transactions in GIS reviewed progress, what they'd said in the speech, what Al Gore had said in the speech, but also the progress that had been made in 10 years towards meeting this vision. And they say it's a worthwhile grand challenge for the GIS community. I think we should consider whether we think it's a worthwhile challenge or not. So we'll just run through, and these are very long lists, but we can just run through these really quickly. So these are the sorts of things described this is the list of what was described in the speech. Embedded georeferenced data in any quantity. Don't really want to read through all these. Multifaceted, multi-resolution imagery, photographs, local information, upload your own data, travel through time, take virtual tours of museums, listen to all histories, collaborate with others, predict outcomes of natural phenomena, create intelligent software, etc., etc. So this is politicians. They like a bit of grandstanding, I think, going on here. Content. Vast quantities of georeferenced information, Earth, environmental and cultural phenomenon, Landsat photography, 1 meter resolution DEM of the world, global data levels, land cover, plants, roads, etc. Citizen science, hiking trails, representations of museum collections, historical data, prehistorical data, dinosaurs, modelled thunderstorms. And of course, you need a user interface onto this, a browsable 3D version of the planet in public exhibits such as museum, head-mounted display, data glove to provide immersive experiences, so they sort of more technology to interact with this data, so not just on the screen, but VR, virtual reality technologies, hyperlink navigation, speech recognition, audio capacity. And you need an architecture to provide this. So databases, content stores, et cetera, quintillions of bytes of information potentially made available, high-speed network you're going to need to connect this all together. We're going to need standard formats, protocols, software, metadata requirements to allow the information to be integrated, interoperability basically, fusion of data from multiple sources. Individuals are able to publish to the system, so VGI capabilities, 2 levels of functionality. Well, we don't want to all that. So EQA, so it's a huge list. So, I mean, that's incredibly brief run through, but 2 questions for you is, what is the current situation in respect of the following? Oh, well, this slide used to be at the beginning and I moved it to the end. Just the points that we've just seen. How much of that has actually come to be today? And is it a realistic and sensible thing to actually be attempting to do in the first place? This is basically a man who's watched too much Star Trek, I think. Perhaps you could say that. But you know, these are visions. And of course, one day potentially that's, you know, ultimately that's what the GeoWeb would like to be able to do. So in the last 10 minutes, I'm kind of throwing it onto you and say, well, what do you think? Do you think it's worthwhile even attempting to do it? Yes? Mm-hmm. Uh-huh. Yes. Sure. I mean, I don't know exactly what you mean in the science views. It's been a while since I've been there, but I imagine it's quite limited.
Yeah, but it's limited to just this because they're showing.
Yeah.
But if the idea is if you can do this like in the real world, right, you can show it to the and do something similar on the net. But to fit all the information in, there is something else.
Well, you don't need. I don't know what you quite fit in from. All right. Well, I won't. Anybody else? What do you think? Is it a good idea? Do you think it's feasible in the next 10 years, 20 years, or should we not even bother?
The thing is that the world is changing, right? So we teach technological innovation, right?
Mm-hmm.
We're always doing new ways to inform people about stuff, about the planet, or about work with them. So at some point, this might happen, you know? You might have something where like, nowadays, you don't, some people don't need to come to lecture. Platform, they can learn from whatever, Wikipedia, from the net, or listen to pre-recorded lecture sessions, you know? So the advent in technology, at some point, you might consider that those things are possible.
All right. So you think? Okay. So it may be.
I'm not saying yes, but it is yes. It can be done. It might be done. You know? But to what extent? That's something that maybe it's possible.
Where is it happening? Give me some examples. What's the nearest that we have to this vision? Can you think of anything that's... Google Earth, yes, probably, in many ways. The globes, yes. Mm-hmm. I think you're right. Google is almost certainly the company that's probably approaching this more than any other. Yes.
It's something that they might integrate, can be integrated.
Can be integrated, yes. Yes, I think that's one important point. While it provides the globe and the potentially, high-res photographs, and there is some data on there. It's not like all data is visible by any means on Google Earth and not immediately accessible. You might have to you've got to find the KML file, hope somebody's produced it, load it up onto Google Earth. So yes, that data is not, and then of course it's in a KML file, it's not a dynamic link. Any other thoughts? I wonder whether the whole thing is really worth, there's a real question as to whether it's worth our effort to try and do it given the complexity of the nature of the requirement. Maybe I'm just being a bit pessimistic, but how difficult, it's taken us a lot of effort to create things like spatial data infrastructures and to get them to work with relatively limited amounts of information, potentially just for countries or something like the European Union, for them to work together to create even data portals onto this information to allow you to download it, never mind all the interaction, the modeling, everything else. Isn't, to a certain extent, what's he describing, mate, a sort of Earth portal onto the internet itself and all the databases onto it? Do you think the technology, what about the technology? If we go back, just page up and just have a quick, just for 5 minutes, just have a look at the other. So let's see, which ones of these have we got and which ones we don't? Actually, we'll go up, up, up. Functionality. View the Earth multi-resolution imagery photographs. Have we got, how many of these have we got? Shout out. Yeah, I think we're pretty good on that, yeah.
You now have a world-based reference system whereby you can on the particular you just format the data to which fits in onto the globe.
It fits in onto the globe, but we'll be careful about that because sorry, at a global scale that's fine, but when you get down to Ordnance Survey level, then you're buggered, aren't you? You're 200 meters or 100 meters out or something like that. So coordinate, that's a great thing at a global scale, but when it comes to local scales, it starts to break down again. Creating visualizations of uploaded data. Does it? Have you looked at Tableau? And Tableau, go and look at Tableau. I think it's Tableaux. I can't remember Tableau. It's a private company, and there's a number of these now that have started up, like CartoDB, like MongoDB, which specialize in maps. These people specialize in charts and interactive graphics and things like that. And now you can upload a data set or a database up to these online services, and you can drag and drop pie charts, dynamic pie charts, graphs, multi-view, time series, in a simple graphical way. So it is actually now, to create visualizations of uploaded data is very straightforward now. Okay, you've got to know that you've got to go to Tableau and sign up and
There's also something on Google like
yeah, there's Google Analytics, these things. I mean, the web visualization has expanded hugely the cloud space with these cloud-based services, and these kinds of things are really rather accessible now compared with what they were 5 years ago. But they're accessible to me, and I would hope to you, but they're probably not accessible to most of the people down shopping in Kingston High Street. Now, whether we need to make it accessible to everybody who's frankly not interested or at the moment is another matter, of course, and how much expertise. Things like taking virtual tours, listening to music histories. Yeah. This one's not really available, really, is it? A great deal. Predictions. Needing simulations, things like that. So some of that's not available. Aggregate system, yes, there's software. So on the data side, functionality there, we're doing not bad. But it's spread among different systems. It's not in one place, is it? So let's just quickly go down. Content, okay, I don't think we need to spend a great deal of time on content. There's a lot of content out there that we know. Clearly, some of it is a bit more accessible than others out there. Sorry? A digital map of the world at 1 meter resolution. Anybody, what resolution can you get digital maps of the world at presently? 30 meters roughly. I don't think it'll take a few years and we'll get 1 meter, I suspect. It's not going to take, not too bad. We're nearly there. The rest of this is pretty accessible, but again, it's spread over different locations. It's spread in different places. Frankly, the Google search engine is the way that you find these data. It doesn't provide a single map-based integrated interface, but it's still there. Sorry? What's that? Again, it's the model data, yes, that's probably more difficult to get hold of. But I don't know whether you saw I posted a link that showed the modeled CO2. Okay, you're not running the model, but you're seeing the results of a model. And that's a different thing. Are you seeing the results of models built by someone else and run by someone else versus can you run the models themselves, your simulation models? Browsable 3D version of the planet. Yeah, I mean, the buildings layer in Google is just amazing. I love it. Public events, museum, head-mounted display. Yeah, these things are Google Glasses now. You know, mobile phones, it's all starting now. Hyperlink navigation, speech recognition, that's a lot better than it used to be. It really is powerful. So yes, all that's sort of there. But again, is it in one place and one? And finally, the architecture, databases, content stores, application software, all distributed. Aggregate quintillion bits of information, participating servers. What do you think? How are we doing there? What's that? Well, I think sorry. Yeah, I mean, in principle, I think a lot of this, high-speed networks, okay, it's not everywhere in the world, but certainly in the developed countries, yes, we've got that. And of course, it's spreading around the world, hopefully, and it will continue to do so. Standard foremost protocols. There's a lot of work being done on that, but clearly there's a lot more to be done. So, it's a work in progress, but in principle, we've got most of the components in place. But again, it's about putting those components together across the whole planet. I think that's the real issue to me. It's as much cultural and economic over technological nowadays. There are issues of technology that there are still issues of, but it's mostly to do with culture and money and desire than it is to do with perhaps, to do with technological limitations. But I still wonder whether really the amount of effort in trying to get it, have you tried to imagine getting, you've done some group work. Imagine you've got a few different opinions among maybe 6 or 8 people in a group. Try doing that with the whole world, with everybody, every type of scientist in the world, and every type of voluntary organisation, and every type of government. Until the new world order is established, I think we're but maybe, you know, and we're moving from a sort of top-down way of running the world to a certain extent. I mean, it's highly arguable, of course. You know, there's the top-down, the government says we're going to do things this way. But there's an element of that in the world, but there's also the bottom-up, that individuals do things and create things that then produce things in a sort of, in a less structured and planned way. And that's a far dirtier world than the federal government saying you're going to use this data standard because we're the government and we supply your money, and if you don't do it this way, we won't give you your money. Whereas individuals, and there's constant innovation, new technologies constantly, new ways of doing things, new ideas constantly appearing. So this great megalith that maybe takes us 30 years, a whole generation and several £100 billion to make, doesn't reflect, by the time it's finished, it's way out of date compared with what's been generated at the bottom and the new technologies and the new ideas that have been created from the bottom up. All right, we'll stop there. So next week I'll introduce you to the semantic web. Who's heard of the semantic web? All right, that'll be new, or at least a new world. Great, okay, and that's the last week of the Cheer Web next week. Brilliant.